Hi friends, in today's video I'm going to be going over two-way frequency tables and how to make them and how we can find probabilities based on them. So two-way frequency tables look like what I have drawn right here, and I'll read the example in a second. Basically, two-way frequency tables are ways for us to present some numbers and data, and we can also find probabilities using the data in the table. So it's like a way to organize data from different situations. So in this first example, and I'm going to do a second example, it's on a different page, but for the first example, we're talking about the Student Government Association, which we can call SGA for short, is surveying 80 juniors and seniors about what theme they want for next year's homecoming. Some of the results are shown in the table below. So we've been given some of the information, but we need to fill in the rest. So I have two columns for the themes. So the two themes they were asking students about were Starry Night and Under the Sea, the themes. And then we've got two rows, which are the two different categories of students. And of course, I have a whole separate column and row just for my totals. All right. Now, we had an important piece of information in the problem that's not in the table yet, which is that there were 80 juniors and seniors total. That means 80 is the grand total of students that we're talking about. And the grand total always goes in this bottom right box because the total juniors and seniors should add up to 80, and the total that said Starry Night plus the total that said Under the Sea should also add up to 80, assuming everybody answered the question. So now I can use some of the information that's already written in red to fill in the rest of my boxes. So if I know that the juniors and seniors need to add up to 80 total students, and I know here that 43 is the number of seniors, then the number of juniors plus 43 should give me 80. So I can really do a little bit of math here. 80 minus 43, that would give me 37. So there must be 37 juniors. So we kind of use the information that we've been given to figure out what's missing. Okay, I can do the same thing with the total of people that said Starry Night. So I know if 35 people said Under the Sea, then the total that said Starry Night plus 35 should give me 80 as well, assuming everyone answered the question. So I can do 80 minus 35, and that gives me 45. So there must have been 45 total people that said Starry Night. Now I can start using this 19 that's been given to me. So if 19 juniors said Starry Night and 45 students total said Starry Night, then 19 plus the amount of seniors that said Starry Night should add to 45. So I can do 45 minus 19, and that gives me 26. If you need a calculator for any of this, that's fine. All right, and then I have two more to find, so I can do the same thing with the top row. If I know there's 37 juniors total and 19 juniors said Starry Night, then 19 plus the number that said Under the Sea should give me 37. So I can do 37 minus 19, and that will give me 18. And then lastly, and you might notice there are sometimes different ways we can get different numbers. So I can either use this row and go across to find this missing number, or I can use the column and go down. I am going to use the column, but you could do it either way. So if 18 juniors said Under the Sea, then 18 plus the number of seniors that said Under the Sea should add to 35. So I'll do 35 minus 18. That gives me 17. So now we filled in our table. It's really just kind of like a puzzle. Now we have a few questions about probability to answer. First, we're being asked, what is the probability that a randomly selected student picked Starry Night? Well, I know with probability, I need the number of ways this event could occur divided by the total outcomes. So in this situation, since there are 80 total students, those are the total possible students that could be asked. So my probability is going to be out of 80, because that's the total amount of students. And then I want to know the probability that a student picked Starry Night. So I need to look not at the juniors that picked Starry Night, not at the seniors that picked Starry Night, but the total students that picked Starry Night. And in this case, that's 45. So the probability that a randomly selected student picked Starry Night would be 45 out of 80. That's the total number of students that picked Starry Night divided by the total students that were asked. And I can also write this as a decimal. You might start seeing probabilities written as a decimal or percent. So this would be the same as saying a probability is 0.5625 or 56.25% if you move the decimal, just to show you some different ways to rate the probability. What is the probability that a randomly selected student is a senior? Well, again, we're talking about out of all of the students, what is the probability it's a senior? Well, there were 80 students. And how many of them were seniors? I can look up, and that was 43. That was one of the things that was given to me. 43 students were seniors. So I can do that in my calculator again. 43 divided by 80. 0.5375 or 53.75%. And the last one asks me, what's the probability that a randomly selected junior chose under the C? Now, in the last few examples, we were just talking about students overall. This one is talking about a junior. So this is actually called conditional probability, and we're going to talk more about this in future videos. Conditional just means that there's a condition here. We're first looking at what's the probability that this person, the student, is a junior and that they chose under the C. So it's like two things that we're looking at. So for this one, I'm looking out of all of the juniors, how many chose under the C. So first I'm going to look how many juniors do I have total, and that would be 37. So in this case, my total is 37 because I'm just looking at juniors. And then the number that chose under the C was 18. So that's how I can find my probability for that. So 18 divided by 37 is I will round it, 4865 or 48.65%. All right, I'm going to do one more example. In example 2, health officials in Washington, D.C. are doing a research study on teenagers with asthma. They are surveying 1,000 students at a local high school. Use the following information to fill in the two-way frequency table. All right, before I even go into this information I've been given, I noticed that they gave me a really important piece of information in the problem, which is that there's 1,000 students total. That's my grand total of students, so that's going to go in the bottom right box. Now, the information they're giving us is a little different from last time. They're giving us probabilities as opposed to numbers. So I'm going to have to use this probability to find the number that goes in each box. So for the first one, it says the probability that a student has asthma is 0.193. Well, if you think back, I'm actually going to scroll back to the last example. The way we found that decimal was we took the number of students in the box divided by the total, and that gave us our probability. So if I'm given the probability, I need to work backwards. So this decimal is equal to the number in the box divided by the total, which in this case is 1,000. Last time it was 80. Now it's 1,000. So to find that number x, like what's the number in the box, I need to multiply by 1,000 to solve for x. So I'm really just going to take 0.193, multiply by 1,000, and that will give me the number that goes in the box. So to do this quickly, I'm just going to move my decimal 3 places, and I get 193. I don't even need a calculator for that. So that means the number of students that had asthma had to be, so I'm looking at the has asthma row and going over to the total number of students, and I'm putting 193 in that box. Because remember, this is just talking about students that have asthma overall. Okay, so all I had to do was multiply by multiply the probability by my total, and that gives me the number that goes in the box. This next one, same thing. What's the probability, or it's telling us the probability that we have at least one household member who smokes is 0.421. Okay, so I'm looking at this column and I'm looking at the total, and I need to do the same exact thing. I'm going to multiply by 1,000, which means I just have to move the decimal 3 places over, so I get 421. All right. Now, I see that I can fill in some things based on what I just wrote. I can find the total that doesn't have asthma right here by subtracting 193 from 1,000. So 1,000 minus 193, that would give me 807. Okay. And then I can also find the total that goes in this box because it needs to add up to 1,000 as well. If I know 421 have at least one household member who smokes, then if I subtract that from 1,000, it'll give me the number that does not have a household member who smokes. So 1,000 minus 421, that will give me 579. Now, we do have one more piece of information given that will help us fill in the rest. We know it's telling us 120 students have asthma and at least one household member who smokes. So has asthma and at least one household member who smokes will be this box here, 120. Now I can use that to fill in the rest. If 120 have at least one household member who smokes and 193 total have asthma, this number plus 120 needs to give me 193. So 193 minus 120, that will give me 73. And then I can use my columns to do the rest. So if 73 in the first column have asthma and there's 579 total in that column, 73 plus this number needs to give me 579. So that would have to be 506. And then same thing here, or you could do the row for this one if you want, but I'm going to do the column. 421 minus 120 gives me 301. Right, that's how you can fill in your table, either by being given, the first example showed when you're given some numbers to put in the table, and this example showed when you're given probabilities.